let's go ahead and find the average value of a double integral. So the average value is the average z value. So typically, or not typically, in traditional calculus 1, you're going to have some curve, and maybe you found the area of this curve. You would have gotten the length that you integrated upon on the x-axis. Let's say the area was 10 and your length was 5. You would divide the area by the length to get the average y value. Say 2, like 10 divided by, like here maybe. But in calculus 3, you're going to be finding the average z value. That's what it means by average value. Now, if you don't care to hear that, let's go ahead and start with the videos. Questions. So this is going to be our function that we're going to integrate, and our bounds of integration are x from 0 to 1 and y from 0 to 1. Now the first thing I'm going to do, I'm going to draw out the graph, because drawing out the graph always helps. And the bounds for x are from 0 to 1, and the bounds from y are from 0 to 1. So 1 is here. Actually, we can actually remove this. Hold up. Let's just do the x, y axis. And our bounds for x are 1 and 0. So 0 and 1. And our bounds for y are 0 and 1. So if this is our bounds, then we're integrating upon this square. So in order to set up the integral, I'm going to write down 0 to 1 and 0 to 1 for the bounds. And our function is going to be inside of our double integral of dy dx, doesn't matter what order you do it in. Now, remember the example that I used where we have some curve. We find the area under the curve, let's say 10. We divided it by our length that we integrated upon. Let's say 5 here. Now we're going to use the area. So we're going one dimension up. We found the length of some line, like 5, and we divided it by the integral. So our integral was 10. Our integral was 10. Let's make this a little better. Our integral was 10. Some AB, right? And our length was 5 for the x. That means we divide this entire thing by 5, or we multiply by 1 over 5. But we're going to dimension up now, so we're going to find the area of our area of integration now. So before it was length of integration calculus 1, now it's area of integration that we're going to divide this integral by. The area of a square that is from 0, that side length of 1 is just 1. So we multiply this, we actually divide this by 1, which is just the same exact thing. But I'll leave 1 over 1 here for the sake of the instruction or understanding. So all this basically is just a double integral. So I'm going to solve for the double, for first the integral of dy. So x plus y dy. Now our integral is still here. Our x integral is still here, but I'm just going to remove it for now so that there's less confusion. And the integral of this with respect to y is xy plus y squared from 0 to 1. I'm going to set these equal to y for consistency's sake. Now if we plug in 1 into our y values, not the x values, that's why I wrote equals y. If we plug in 1, we get x plus 1/2. If we plug in 0, we just get 0, so we don't have to worry about this bottom term. Now we integrate this. So we integrate x, integrate with respect to x now, because we still have this integral over here that we haven't done yet. If we integrate this with respect to x, let's actually fix this d. You get x squared over 2 plus x over 2 integrated from 1 to 0. And we set these equal to x. We can plug in our 1 value, and all we get is 1/2 plus 1/2, which is just equal to 1. And 1, and we have to, well, we have to multiply it by 1 over 1. But this is our volume that we got from the double integral, and we just multiply it by the reciprocal of our area. So 1 over 1 is equal to 1. So the basic formula is just your bounds, A, B, C, D. Actually, I should write some region, matter of fact. So we're integrating upon some region. It could be R, it could be S, whatever. And you have our function integrating upon dA. So we're integrating upon some area. And we multiply by the reciprocal of our region's area. So we find our double integral, and then we multiply by the reciprocal of our region that we're integrating upon. Okay, for the next question, our function will be f of xy is equal to x squared plus y squared. And our x bounds will be from -1 to 1, and our y bounds will be from 0 to 2. Let's draw this out. So x from -1 to 1 is just along here, and 0 to 2 for our y bounds is just along here. Matter of fact, this is actually a square, so let's draw this to scale. And this is the region we are integrating upon. We can actually figure out that this point here is 1, 0. This point is -1, 0. This point is -1, 2. And this point is 1, 2. But they're just the intersections of these lines that we got from our region. Now that we found this, we can find the area of the square. Basically, the side lengths are just 2. So 2 and 2. So 2 times 2 equal to 4. That is equal to our area. The area of our region, you can put R of A. I'll just put A. So if we set up our double integral, our y bounds are 0 and 2. Our x bounds are -1 and 1. Our function is x squared plus y squared. And remember, the order which we put the dy and dx matters because they are going to correspond with our integral values. So our y bounds is 0 to 2, and our x bounds are -1 to 1. That's why x is on the outside, and this integral is on the outside, and dy is on the inside, and this integral is first. This is the integral we're doing first, and this is the integral we're integrating with respect to first. Now, once we have this, we have to multiply it by the reciprocal of our area. So 1 over 4. Now let's start this problem. 0 to 2 for x squared plus y squared with respect to y. This just turns out to be x squared times y plus y to the power of 3 over 3 from 0 to 2. We plug in 2 here, you get for y. So we plug in 2 for y. With 2x squared plus 8 over 3. Now we integrate this with respect to x. So 2x squared plus 8 over 3 with respect to x. Then we get 2 over 3 x to the power of 3 plus 8 over 3 times x. -1, 1. And let's go set this equal to x. Equal to. Let's go plug in our value. So we get 1, 2 over 3 plus 8 over 3. Let's fix the 8. 8 over 3 minus, so to put parentheses, make sure you put parentheses if you're using the bottom bound, minus the bottom bound. So we have negative 2 over 3 and negative 8 over 3. And this all simplifies to what? This is like 2 plus 8. This is 10. This is 20 over 3. I can actually fit this at the end here. Equals 20 over 3. Now let's not forget to multiply by 1 over 4. So we get 1 over 4 times 20 over 3 is equal to 5 over 3. So this is our average. This is the average z value along this integral. This function's integral. So for the next function, we will use sine of x plus y. And our region will be from 0 to pi for x, and y is 0 to pi as well. So if I draw this out, all we need is the first quadrant. So I'll just draw the first quadrant, and 0 to pi is, let's say, here, and 0 to pi for the y axis is, let's make this look like a square somewhat, let's say here. So if our side lengths are pi for this square, then our area is just pi squared, or pi times pi, or pi times pi. So this is equal to our area. Now that we found the area, all we have to do is write down the reciprocal of the area. So just put 1 over it. We find our double integral from 0 pi to the y bounds and 0 pi to the x bounds. We put our function inside, sine of x. Oh, I put a comma there. I didn't even notice. This is plus y. X plus y of dy dx. Again, doesn't matter which order you integrate upon. Just make sure you switch the bounds. So let's find our first integral. Let's find our dy integral first. So sine of x plus y of dy is equal to cosine of x plus y from 0 to pi. Now if we plug in pi for y, we get cosine, this is negative cosine technically, I forgot about that. You get cosine of x plus pi minus negative cosine x plus 0, which is just x. So this is our first integral with respect to y. Let's go ahead and do our integral with respect to x. So now we have cosine, negative cosine of x plus pi plus, because these negatives cancel out, cosine of x of dx. Let's go ahead and find this integral. This integral will be negative sine of x plus pi plus sine of x from 0 to pi. And if we plug in our values for pi and 0, we get negative sine 2 pi plus sine of pi minus negative sine of pi plus sine of 0. And to simplify this, this just turns into 0, 0, 0, 0. What in the world? So everything just zeroes out. So this integral is equal to 0. Well, now that we have 0 for our integral, you just have to multiply 0 by your reciprocal of the area that you're integrating upon. 0 times pi over 2 is equal to 0. So our average z value is 0. So to quickly recap, let's write the general formula down of what we did. So you're going to have some integral, and you're integrating upon some region. You're going to have your function. You're integrating upon area, and you divide it by the area of the region. So this general formula gives you everything you need. All you have to do is first find the area. An easy way to do that is to draw your picture, draw your graph, and then solve for whatever shape or square or circle that you are integrating upon. Save that area and use it later on. And all you have to do is solve for this integral, this double integral. Once you solve for the double integral, just divide it by your area or multiply by the reciprocal of your area. So if you have any questions, put it down in the comment section.